Sixth question is, in the circuit shown in figure, find the total current from the supply and the current in 90 ohm resistor. So you have to use the star delta transformation in this figure. So the first delta 50 ohm resistor, 70 ohm and 90 ohm resistor delta connection is converted into star connection. So you have to find RAO, ROB and ROC. So you will get all these resistance by using the star delta transformation. Then we are taking the equivalent resistance. So uh, this 90 ohm resistor, that means 630 plus 60, 90 ohm resistor, and 21 plus 80, 101 ohm resistors are in parallel. So we are taking the equivalent resistance 48 ohm, and which is in series with a 17 ohm resistor. So we are getting the equivalent resistance as a 65 ohm resistor. So current in the circuit I is equal to 200 volt divided by 65 is equal to 3 ampere. Then you have to find the current in 90 ohm resistor. So current in 90 ohm resistor means the voltage drop or the voltage across BC, the terminal BC. So VBC divided by 90 ohm resistor, you will get the current in 90 ohm resistor. For that, you have to find V1. V1 voltage across 70 ohm resistor and V2 is the voltage across 65 ohm resistor or the equivalent resistance 65. So V1 you will get 51 volt and V2 is V minus V1. Then I2 through 90 ohm resistor, then I1 through 101 ohm resistor. So you will get I1 and I2. Then you can find VOC, voltage across ROB and voltage across ROC. So VOB and VOC you will get. Then point C is at a higher potential than point B by VOC minus VOB. That is equal to 18.63. So that is VBC. That is divided by 90 degree is equal to the current in 90 ohm resistor, which is equal to 0.21 ampere. Seventh question is, derive the expression for the RMS value of a sinusoidal voltage. I have already explained the expression for the RMS value of a sinusoidal current. So in that case, you have to replace voltage in current. So the equation will be V is equal to Vm sine theta. Take the squared way, V square is equal to Vm square sine square theta, and take the integral, and you will get the final answer as V is equal to Vm divided by root 2. The value is 0.707 Vm. Eighth question is, derive the EMF equation of a single phase transformer. So what is a transformer? A transformer is a static machine which transfers AC electrical power from one circuit to another without any electrical link in between. So what is the working principle of a transformer? When a sinusoidally varying voltage V1 is applied to the primary, an alternating flux phi is set up in the core. This flux links both the windings and induces EMFs E1 and E2 in them according to Faraday's laws of electromagnetic induction. E1 is called primary EMF and E2 is called secondary EMF. According to Lenz's law, induced EMF acts in opposite direction to the applied voltage V1. So E1 is equal to N1 d phi by dt, E2 is equal to minus N2 d phi by dt. E2 by E1 is equal to N2 by N1 is equal to K. K is called voltage transformation ratio and 1 by K is called turns ratio. So for the ideal transformer on no load, that means the secondary is open circuited. Now the primary can be treated as a coil of pure inductance. When an alternating current V1 is applied to the primary, it draws a small magnetizing current Im, which lags behind the applied voltage by 90 degree. This alternating current Im produces an alternating flux of phi which is proportional to and in phase with it.
The alternating flux phi links both the windings and induces EMF E1 in the primary and E2 in the secondary. The primary EMF E1 at every instant is equal to and in opposition to V1. Both EMFs E1 and E2 lag behind flux phi by 90 degree as shown in phasor diagram. However, their magnitude depend upon the number of primary and secondary turns. So, the EMF equation of a transformer is consider an alternating voltage V1 of a frequency F applied to the primary of the transformer. This develops a primary current which sets up an alternating flux phi, which can be represented as phi is equal to phi m sin omega t. Instantaneous EMF induced in primary is E1 is equal to minus N1 d phi by dt. So that is equal to minus N1 d phi m sin omega t divided by dt minus omega N1 phi m cos omega t. So differentiation of a sine is cos. Then minus 2 pi f, omega is 2 pi f N1 phi m cos omega t. 2 pi f N1 phi m sin omega t minus 90 degree. So minus cos omega t, we can write it as sin omega t minus 90 degree. It is clear from the above equation that maximum value of induced EMF in primary is EM1 is equal to 2 pi f N1 phi m. So RMS value of E1 primary EMF is E1 is equal to EM1 divided by root 2. That is equal to 2 pi f N1 phi m divided by root 2. The value is E1 is equal to 4.44 f N1 phi m volts. Since the flux phi is common to both windings, E2 is equal to 4.44 f N2 phi m volts. In an ideal transformer, E1 is equal to V1 and E2 is equal to V2. So this is the answer. Ninth question is, a 50 Hz 4-pole 3-phase induction motor has a rotor current of frequency 2 Hz. Determine first one the slip and the second the speed of the motor. So how will you find the slip? Slip is the difference between the synchronous speed and the actual speed of the rotor. So it is usually expressed in percentage of synchronous speed. So percentage slip S is equal to ns minus n divided by ns into 100. And rotor current frequency is equal to slip into supply frequency to stator. So rotor current frequency is expressed in Fr, not denoted by Fr, is equal to Sf. So the slip S is equal to Fr divided by F, rotor current frequency divided by supply frequency. So that is equal to 2 by 50, that is equal to 0.04. So 4 percentage. Then next is the speed of the motor. You have to find the speed of the motor. So ns, synchronous speed ns is equal to 120 f by p. 120 into f is the supply frequency 50 divided by p, 4 poles. So 4, that is equal to 1500 rpm. So slip is equal to ns minus n divided by ns. So 1500 minus n divided by 1500. So you will get the speed of the motor n as 1440 rpm. 10th question is, what are the requirement of a good lighting system? First is sufficiency. Light need to be sufficient to see the object properly. Second is distribution. The efficient vision without any eye stresses occurs by uniformity in light distribution. And third is absence of glare. Glare is high contrast of light. There should be excessive light and high intensity of light goes to glare. And fourth is absence of sharp shadows. Shadows occur when any object takes place between the light source and field of vision. Shadows create stress and need to be clear for proper reading process. And fifth is steadiness. The term refers to stable condition of light. Light must be constant with constant contrast and constant intensity. Sixth point is color of light. Is there any problem by using colored light? Yes. The daylight is the sufficient illumination needed by eye to fulfill reading process. Artificial lights need to be like daylight contrast. The next is surroundings. The term refers to background field of vision. As a requirement to good lighting, background has a major role. The walls in your rooms and ceilings are creates reflection and it's essential to accumulation of light. And next is angle of light. The light source should be established in a proper way that lead to effective lighting by reflection.